Okay, ball of mass small m makes a head-on elastic collision with a stationary ball of mass big M. Rebounds with a speed equal to 1/3 of its original speed. So that was stationary. Yep. That's obviously not stationary. So that's before, after. So it rebounds. Call that velocity v. So this is a third v. That will move somehow that way. Show that the mass of the second ball is equal to 2m. So show that m equals 2m. Okay, so this is a collisions problem we've got. So this is small m. This is big M, we don't know. We also don't know we're not told its velocity, call it u. Therefore we've got two unknowns, mass, and we've got its velocity. So we're going to need two equations to do this one. First one is clearly momentum conservation. So momentum conservation is going to say that the momentum before, so mv, that's momentum before, is going to equal, so afterwards we've got m times a third v, but it's going the other way, so we're going to put that as a minus sign. Plus big M times U. So that's one equation, but that's not enough to answer the question. So the key thing here is to look at what extra information is given, because in a collision question, momentum on its own is never going to be enough. So the key word here is elastic collision. So elastic, that implies that energy is conserved as well. So kinetic energy before equals kinetic energy after. So kinetic energy before is half small m v squared. Kinetic energy afterwards is half m, and then it's a third v all squared. And of course, it's positive energy, it doesn't matter whether it's going that way or that way. You square the v, if it's minus sign, minus squared is still a positive number, plus half m u squared. So now we've got two equations. Two unknowns. Let's solve them. So our unknowns are m and u. We want to find m. Yep, so if we find what u is and substitute it in, we should get an equation for m. So one implies, so we want to find the equation for u, so move that over there. So 4/3 mv equals mu, which means that u equals 4/3 of m over capital M times v. Substitute that into 2, you're all right on the screen there? Yep. So we've got half mv squared equals half m. Let's multiply that what we can, so that's a ninth v squared plus half capital M times u squared, so that's 4/3 squared, which will be 16/9 m squared over capital M squared times v squared. What can we cancel? We can lose one of those m's. We've got v squared everywhere, so we can cancel the v squares, just divide by the v squared. So we've just got, let's just go on that way, algebra. So we've got half m equals an 18th of m plus 16 18ths of m. Was it m squared? No, 16 18 m squared over m. Not sure this looks right. Anyway, we take out one of the m's. Solve for m, so we've got half minus an 18th equals 16 18ths m over m. Let's make everything 18ths, so 9 18ths minus 1 18th equals that, so we can then multiply through by 18. Oh yeah, 8. 9 minus 1 is 8, 8 equals 16 m over m. So bring the m up, the 8 down, 16 over 8 m, so not half, 2m.
There we go.
Bit of algebra there. So momentum conservation, energy conservation. I don't think there's any other way you can do that question. Okay.